In this video, we're going to talk a little bit about how we obtain those theta parameters or our model parameters. So we're going to talk about optimization here. Okay, and we're doing that with something called a loss function, and I'll talk a little bit about this, and show you one of the simplest loss functions and actually widely used, mean squared error. So I'm going to go back to our Excel file, a few good things to know about Excel, and there is a tab for optimization within that. Okay, here we go. There's a lot on here. I know, off to the upper right-hand corner is kind of instructions for how you find Excel solver, which I'll show. But also if it doesn't appear under that tab at the top, there's a certain set of instructions for how you go into the settings and make sure that it appears. But for here, let's just go through a simple optimization example using Excel's solver tool. So if we look off to the side, here we have our thetas. So again, we're just going to start off with a random number for each of these, and then if you look down below, x1 through x10, so we have 10 different input variables within this. And there's a few different runs here, so you see this number of runs. Similar to how we've done in the past, we need to start somewhere. So in this example, we have these 10 inputs, but we also have a target or an output. So in this case, we actually have a value that then has been measured, and we want to create a model that will actually predict that target. So the simplest model is going to use this matrix multiplication, and we're gonna, once again, we want x, so select all our x's, comma, and then we're gonna select all of our theta values. Close parentheses, enter. So what you can see right away is we have values ranging from 2.577 up in this first row to some higher ones. Here's 3.64, but our targets are in the hundreds. So there's a big difference. So one of the things that we do is there's something called a loss function, which is the difference between what we want our prediction to be and what our prediction actually is. So here we can use the simplest one, which is the mean squared error. So what we'll do is we'll take the target values, we're going to subtract our predictions, and then we're going to square it. The squaring means that, like if you have negative values there, by squaring it, everything becomes positive. And actually the magnitude of this number tells you how close the prediction is to what the actual output was. Here we want to take the average of that. So within Excel, it's just a function called average. Since this is a dynamic array, we can select P15 and then add the hashtag or the number symbol, and that's going to select all of those loss function values and take the average of it. Okay, so now we have an average, again, 289,000, so something that's very large. That means our model is very far away from the output values that we want it to predict. So now we're going to actually use this solver function. So if you look at the different tabs up above, I'm in the data tab, and then all the way over to the right here is the solver button. And so this is what we're going to use to actually optimize these model parameters. So I click on solver, I'm going to actually go over here and make sure that you can see it too. So there we go. So now within solver, set objective. So this objective function, if I click on this up arrow, I can select it. That's the average value. So it wants you to have like one value that it's going to try to target and optimize. So there we go. We have that P26, or that average of the loss functions. We want to minimize this. So if we minimize this, then that means that our model prediction is getting closer to the target values that it's trying to predict. And we want to do this by changing the model parameters. So we would select theta naught through theta 10 as all of our model parameters that we want the model to change. So as it's trying to optimize and minimize this loss function, or this average of the loss functions, we want it to change the model parameters, our thetas, in order to do that. The rest of this we can leave the same. You can look into different constraints and options and how that might work. But now we can just select solve. Okay. And it's actually went and solved that. I can click off this screen. You can see the average now. This is times 10 to the -5th. So something very, very small. You can see that our predictions in this Y column are very close to where our target is. So it did a really good job of actually modifying these theta parameters. You can see up in that corner. In order to make a model or a function that accurately captures those target values. And now that we have these theta parameters and we've trained a model to do this, now we can make a prediction. So here's a prediction that has, again, 1 in this theta naught column, 0.5 everywhere else. So we just chose, 0.5 as a random number, so to speak, just to test it out. And now we can do matrix multiplication. And we want the x's, which is this new row that we want to make a prediction on. And we can use our model parameters up at the top to make a new prediction. So with this, we have now created a model. We've optimized it such that the model parameters accurately reflect, this test set that we gave it and these target values. And then we can now use that model with these model parameters to make new predictions.